Unit 1, Section 2.3, Worked Examples. In the first example, they give us the universal set and then two sets within that universal set. The universal set is a set of cities in a country. Set A is a set of cities that have a zoo, and set B is a set of cities that have a convention center. And we want to describe B prime, which is the complement of B, in words. So if B is a set of cities with a convention center, then the complement of B would be the set of cities without a convention center. The second question tells us that set U is a set of farms in a certain country, and set A is a set of farms in the country that produce wheat. Set B is a set of farms in the country that produce peas. Describe the set A union B in words. Now we know that A union B means it belongs to set A or B or both. Choose the correct answer below. All right, so let's take a look at the answers and see which one would be A or B or both. The first one says the farms that produce wheat and produce peas. We can eliminate B. We can eliminate B because it notices it uses the words do not produce wheat, which would be A prime. And C also includes do not produce wheat, which would be A prime. We can eliminate that one. Answer D is two complements, which we're not dealing with. Set E, or answer E, is the set of farms not in the country, which is not correct. So it looks like answer F must be the correct answer, the set of farms in the country that produce wheat or produce peas, which is correct. Let me erase this over here. I didn't mean to cover that up. There we go. All right. Okay, another example with three sets. So U is the set of colleges in a country. A is a set of colleges that have a baseball team. B is a set of colleges that have a physics department. And we want to describe A intersect B complement. So let's talk about what B complement would be in words. So B complement is going to be colleges without physics. Since B is the set of colleges with physics, then B prime would be the set of colleges without physics. And so if we take A and we intersect it with B complement, we're going to get colleges with baseball, and no physics, because the intersection, remember, the connector word there is no physics, is and. Okay, next example, let U be the set of all tax returns, and we want to talk about the set B union C. And set B here is a set of tax returns showing business loss, and then the union that means, or C is tax returns filed in 2008. So we want the set of all tax returns showing a business loss or filed in 2008. And if I look at my answers here, it would be answer B is the correct answer. Okay, for the next problem, we have four sets. We have the universal set, and it's going to be the set of numbers such that n is a natural number and it's less than or equal to 9. So I'm going to go ahead and write what elements would be in there. And it would go from 1, 2, 3, sorry, my pen is not writing very well today, 3, back up, 3, 4, 5, 6, 7, 8, and 9. And we want to deal with A intersects C complement. So let's go ahead and write out what's in A. And A is an even. So A is going to be an even natural number less than 9. So A is going to have 2, 4, 6, and 8. And C is a natural number between 1 and 6 non-inclusive. So let's write out what's in C first before we find C complement. So C is going to be 2, 4, 2 and 4. I'm sorry, that's not right. It's not even, so hold on a second. Didn't say even, so it's going to be 2, 3, 4, and 5. And therefore, C complement is going to be what's in the universal set that's not in C, and that's going to be 1, 6, 7, 8, and 9. And then we want to do the intersection here of A and C complement. And so what do we notice is common there? And it's the elements 6 and 8. So if I look at my answers, and the correct answer here is going to be answer D. And you really do need to write out the sets in order to be able to tell what the elements are and what's going to be in the complement and then also in the intersection. So for the last problem, it tells us that a certain number of people voted for a politician in his first election, a certain number in the second election, and then so many voted for them in both first and second. How many people voted for the politician in any election, first or second? And we know the number of elements in A union B, which is what they're asking me for here, is the number of elements in A, which is going to be the 1, 2, 7, 7, 9, plus the number of elements in B, and we're going to minus the number of elements in the intersection. And so if I pull up my calculator, and pull it over here so you can see it. So I'm going to take 1, 2, 7, 7, 9, and I'm going to add the number that voted in the second election, which was, oh, let me clear this out. We had some numbers in there from before. 1, 2, 7, 7, 9 plus 1, 2, 7, 8, 1, 2, 7, I'm sorry, 1, 2, 7, 9, 8. And then I'm going to, let's pull this up here, subtract 8456 minus 8456. And so 17,121 voted for this politician in the first or the second election. So again, I added the 12,779 plus the 1,2,798 and then subtracted the 8456 and I got 17121. And again, that's using this rule shown here on the screen, which is the rule for finding the number of elements in the union of two sets.